So as Josh said, I'm the technical director at CustomD, and it's kind of my job to oversee all of this and make sure everything's secure and all that sort of thing. So we obviously, in New Zealand, just kind of going back a little bit. For some reason, my presenter notes aren't showing up here. It's kind of annoying. Is it because it's not mirrored? Here we go. Go like that. So give me a sec. Okay, should be able to go like this. Right, there we go. That's better. All right. So in New Zealand, obviously, we've got the Privacy Act, and that sets out, the 13 privacy principles. So summarising those, if you have a reason to store and collect personally identifiable information from users, then it's your responsibility to ensure that information is kept safe and secure. So that's the part we care about today. It says a few other things as well, but so the most comprehensive protection for your data is obviously encryption. So you can do all sorts of other access controls and so on, but the best thing you can do is to encrypt your data. So in Laravel, if you are currently storing, personally identifiable user data or commercially sensitive information, you might already have heard about the Illuminate Crypt library. So that's documented on the Laravel website, and it basically looks like this. So you simply encrypt your string, and then you can decrypt it. Boom, job done. We've got encryption. We can go home, grab a beer, chill, whatever your vice is. But is that really secure? Not all encryption is made equal. Well, are we winning? We don't know. As with anything, it really depends, right? So for starters, Laravel's crypt library uses your app key as its encryption key behind the scenes. If you can guarantee that that app key will never be seen by anyone else but you, then yes, you're done, you can go home. But when it comes to security, it's best practice to follow the "you will be hacked" mantra. And so basically, if you have valuable information, you will be hacked at some point, whether you know about it or not. If you're uncomfortable with that fact, then you'll need to figure out a way to mitigate that. So there's too many individual parts at play to prevent a data breach altogether, right? You might be compromised by a composer package or an out-of-date server software or even a fully patched operating system that has a zero-day vulnerability. It's unavoidable. There's not really that much you can do about it. The best you can do is to keep your stuff up to date. But even then, as we've seen in recent days, there's some composer packages have been compromised, and you just have to keep on top of that. But let's say someone gets access to your server where your Laravel app's running, and immediately they've now got access to your environment. They can see your app key, and they can decrypt all of your data. So if you're using the Laravel crypt library, that's gone. So they don't even need to copy a copy of your app to decrypt it, and they can just take a quick dump of your database and install the Illuminate encryption package and define the same app key, and they've got access to every piece of data encrypted with that whenever they want it, for as long as you're using that same key. Consequences could be dire. So what does mitigation look like? How do we plan for the worst and limit the impact of a data breach to avoid that? Well, turns out there's a couple of very different types of encryption. We've got symmetric encryption, and we've got asymmetric encryption. So symmetric encryption is what the Laravel crypt library uses. This uses the same key to encrypt and to decrypt the message that you're securing. Nice thing is it's fast and secure, provided your keys can stay secure, and you've got unlimited message sizes. With asymmetric encryption, it's quite different. So it uses a key pair, a public key and a corresponding private key. So put simply, with asymmetric encryption, you can use a public key to encrypt the message and decrypt with the private key. George wants to send Nancy a secure message. So George sends the system his request saying, give this to Nancy. System takes Nancy's public key. And remember, it's public, so there's no need to keep that secure. And it uses that to encrypt the message. When Nancy logs in to see her new message, system takes her user's private key and decrypts the message. So only she can access that message. Nancy's private key can be kept safe and secure because it's not encrypted, because it is itself encrypted on the server using a key derived from her password. And because we never actually store her password in plain text, we use a one-way hash. No one can decrypt her private key without first finding out her password or watching her login or something along those lines. So this is a potential solve, to our issue. There's some drawbacks though. First, asymmetric encryption is much slower. And second, this is the big one, the public key can only securely encrypt very short messages. In fact, they have to be shorter than the key's length, which kind of limits you to, depending on your key length, it limits you to only a few characters, and you might not be able to encrypt everything you need. So that rules it out for most applications. You could get around that by encrypting the data in blocks, but because asymmetric encryption is slow, that quickly causes performance issues in your applications. So smarter people than me thought up a really great idea. Why not use both? A hybrid encryption. That combines symmetric and asymmetric encryption techniques to get around the message length issues and the performance issues. So basically, we generate a random symmetric key, and we use that to encrypt our record, take a copy of that key, then encrypt the copy of the key using the public key of all the users or user groups that need access to that record. To decrypt, just reverse the process, take the user's private key, decrypt their copy of the symmetric key, and then decrypt the data. You might not realize this, but you're actually already using hybrid encryption. This is how SSL works. Generates a random session key, our symmetric key, and shares that with the server by encrypting it with the SSL public key. And the server decrypts the session with the private key. So if you've ever set up SSL on a server, you might know about that. So with all that done, even if an attacker completely owns your server and can watch every request coming into your system, they can only decrypt data for the specific users who have made requests while the attacker was present in the system, and only while that specific session token is active. So the idea being that when we're storing their private key in the system, we rotate it based on the user's session token. So you need the session token that gets sent with every request, like a bearer token or whatever, to be able to decrypt the private key for that request. Mitigation successful. Now we're winning. Implementation. So as you've probably guessed, maintaining all that logic and managing the key store can get pretty tricky pretty quickly. As we've seen, encrypted data is only as safe as the keys we use to decrypt it. So to this end, we've built a package which automates most of the process for you. that's the package there. Now we'll have a bit of a play around with it. Show you how to get set up. So I'll switch this back to mirroring. And we'll jump over here. So I've set up a completely fresh Laravel 8 installation. A couple of things to note if you were watching or here at the last session, you would have seen Craig using this command, fin. That's just because we use Doxel, which is like an environment containerization thing. So fin just gives us a command into the container. So basically all of my examples you can switch out fin for PHP. So you'll see me typing fin artisan, PHP artisan, you know, you can figure that out. Right. So first thing we're going to do is we're going to install the library. So composer require. But I've already done this, so I will switch over here. So yeah, once you install the library, the next thing you need to do is basically just publish the config and migrations. So the library is available on GitHub, just here. You can also see it through Packagist, and it's got, you know, reasonably good documentation. We spent quite a bit of time documenting it, and we're using it on several projects in production already, so it's well tested and well patched and maintained. So I'll just make sure everything's up to date there. Very good. So yes, once we've installed it, we just publish the config file and the migrations. So there's a couple of things that we get. We get this config file here, which lets you change the encryption engine. Comes with a standard one out of the box. Most of the time this will suit your needs perfectly, but if you ever have a need to switch it out, we've tried to build the whole package so that you can do what you need and switch all the components out if you need to, if you've got a good reason to. The tables config allows you to use a different engine per table. So if you've got a completely different need for a different type of encryption for one table versus another, that's catered for as well. Then we've got config for your public key and private key. We define the storage path, so its public key as a default location, and then this is for the global encryption key provider that we provide out of the box, but I'll come to that a bit more detail later. And then we've got the different models, so you can override the base models that we use in the package for your key storage and key management. And again, that's completely optional. You can roll with the ones that we provide, or you can customize them as needed for your purposes. So yeah, the global key provider doesn't really give you any major benefits over the encrypt string in terms of security. What it gives you is a lot more convenience in that when you bind the model encrypt to a model, it will automatically encrypt and decrypt fields for you on the model as you're saving it without you having to do a thing. So it just saves you that extra work. So if if you're happy with the risk of using a key on the server, then that's all you need to do. You don't need to do any of this other stuff, which I'll show you later. So first thing we want to do is migrate. I'm going to say fresh. And you'll notice that when we published our migrations, tell me if this is too small for you to read. Cool. I'll just open this in here. Yeah, cool. So the first migration that the package publishes is this one. This is to create your RSA keys. It adds a ID relationship to your users table. Now this is optional. It's not used out of the box with the key providers that we provide out of the box, but it will come in useful if you're doing public-private key encryption like I talked about before. Then you've got the key store and the key store keys table. So this is where we store all of our synchronous keys, and this tells us, okay, we've got this table and this record. This is the key to the synchronous key to encrypt and decrypt that record. And then the key store keys table links your user key or your public-private key pair to that synchronous key, right? So it has the individual user's copy of that synchronous key encrypted with that user's public key, so that they can then decrypt the synchronous key, and away we go. Make sense? So next step we'll run fin artisan async key. This should actually be called asymmetric key. That's all right. We're going to fix that up in the next version. Cool. So I've already done that. You can overwrite them if you want to, which I will not do. Bearing in mind, if you overwrite these async keys, you will lose access to all of your previously encrypted data, which may or may not be what you want. I don't know. So then the next thing we will do is we'll make a model, and we'll figure out how to bind this library to our model. So I'm going to create the contact model, which I've already done because I checked out the branch. So we'll have a look at that. Basically, what I've done here is added in this, which is a trait that the package provides you, and it has all of the logic for how to encrypt and decrypt your records and all of the events so that your record will get encrypted when you save that model. So I will show you how that works. Oh, sorry, before I jump into that, we'll go back and have a look at the migration for the contacts table. So couple of important things in here. You'll see we've got these field types defined in here, and these come from the package. We have an extension to Blueprint and Schema, which the reason behind these is that, as you probably expect, when you say I want a string of 100 characters to Laravel, it will create a varchar field with limit of 100 characters, right? That is not necessarily going to be big enough to store your encrypted data. So we have some logic behind the scenes there to work out what the maximum size of the encrypted string would be and to create a proper field type for that. So if we have a quick look at the database, you'll see the context table has name 100, but you'll see in here that it's actually created a text field. So that's something to be aware of just when you're designing your database. And that is just so that we can fit all of the encrypted text into that field. So for example, if I were to say 10 characters and migrate fresh, you would see that it's now varchar 188 because it's calculated that 188 characters is the maximum length. More or less, yep. The other thing you might notice is this is a date field, whereas it actually gets created as a varchar, again because you can't store an encrypted date and expect to be able to search on it as a date anyway. Yep. I'm not going to explain it in detail. All that documentation is in the package. Suffice to say, it can be done. And I'll talk briefly about a bit about how it works as well. Cool. So tinker time. Yep. Sorry? Yeah. So what we're going to do. Yep, I did. Just to make sure. Maybe I didn't. Who knows? Thanks, guys. Got my back. Cool. So we'll just create a contact, right? So once again, we'll have a look at the contact model. Contact model has 3 encryptable fields and 3 fillable fields. These don't have to be the same. They just are in my demo, just cause. And we've got this key providers array in here. Now, this key providers array can be whatever key providers you want. There's a methodology in the package, which I'll show you later. There's there's an interface for creating your own key provider, and we will actually build a specific one in this demo. But like I say, the global key provider out of the box gets you up and running fast, and we'll see how that works. So we'll create our contact, and look at that, and we've got some encrypted data right there. Open up the database. Here's our record. Probably can't see that. I don't know, I can blow this window up, but in any case you can see it here. So how do we get that data back? Well, if I go, if I find the contact, again, you just see all the encrypted data. Now that's because we have a performance optimization in there. So it will only bother trying to decrypt the data if you actually try and access that attribute. So when I say contact name, you'll see it comes back as John, which is indeed what I saved. Same with birthday and address. Yep, to array. That's a good. Cool. So you can basically use your model as you normally would in Laravel, completely transparently without really thinking too hard about it. Couple of limitations. Because we use model events to trigger the encryption, you can't use any kind of mass assignment methods, so we actually block them off for these models. So we prevent them and throw an exception to say, hey, this is an encrypted model, find another way of doing it. Of course, you can still do a manual query or like a DB command to manually write those and deal with the encryption however you need to for that particular use case. But otherwise, you know, sticking to those kind of single operations, single model operations. Cool, so now that we've got some simple encryption up and running, let's switch this to a user-based key provider with public-private by users that I was talking about before. So for this, we're going to use the documented example UserKey Provider, but we don't have a package for this just yet. We're going to be putting one together as a kind of a starting point for you to do whatever customizations you like on top of. But for now, we've got this this documented here. So again, oh, I should do that one day. Switch to the next branch. Now, there's a few things going on in here. The main thing in user, you'll see we've switched. We've added this trait user key store, which has all of our. So we've added this trait user key store, which provides all of our logic for managing public-private keys on the user. So this does a few kind of useful things. Basically, when you're creating a record, it takes your user password, creates a key pair, and then hashes the password to store on your model, which is probably something you tend to do on your user models anyway, unless you just hash them in the controllers or whatever. But this is quite a good good pattern, and you don't have to think about it wherever you are, even if you're in Tinker or whatever. Similar for updating. If your password is changed and the password is already pre-hashed, we throw an exception to say, actually, we need the plain text password to be saved here so that we can create a new private key. For this to work, we have to have a private key in the user session. I'll talk about how that gets there in a minute. But then, again, we do the same thing. We hash the password and we run this little action. I'm not sure if you've seen this kind of action pattern before, but it's quite a handy one that they're starting to use in some of the core Laravel packages. And basically, it's you add this actions folder and you create these little classes which have kind of single use functionality, or kind of reusable functionality rather, you know, that you can pull in across your app wherever you like. So this particular one uses the packages set private key method, and it will basically save a new it will basically save the new version of that private key encrypted with the user's password. Make sense? Nope. Nope. Just the user's private key, because we've got the user's private key already in session, and I can talk a little bit about how you handle password resets or forgotten passwords. This particular process assumes that you've already got the user's private key in their session, and this is a password present password reset. Right, so they've logged into the admin area, they've gone to, change my password, entered their old password and put in their new password. In the case, I'm not specifically going to demo it today, but in the case of forgotten passwords, what we tend to do is we have a secret question answer mechanism where we basically get people to save, say, 1, 2, 3 secret questions, and the answer to that secret question becomes the key for a copy of their private key. So that why we do that is if we can restore their private key as is, we don't have to bother re-encrypting everything. So even if they've forgotten their password, they provide an answer to the secret question, and away we go. Disaster scenarios, you basically have to have a master key. So one user or a system user has a copy of all of the synchronous keys that they can then restore. That's not required, but
one of the ideas behind the global key store was you would actually keep the global key store running, but the private key would not be stored on the system. So encrypt everything, and eventually you need to shut the private key back on.
Yeah. So for example, you might store the private key in something like Bitnami, or sorry, what's it called, HashiCorp Vault, or something like that. And then when you, like Craig says, when you need to restore it, you just pull it in then. But that's kind of a manual recovery process. So the meat of the package is this key providers. So we'll just find that. So essentially, the key provider abstract tells you that you need to create 2 methods, and one is get public keys for table, and the other is get private key for record. So what this is doing is it's saying, okay, this is the record that I want to encrypt. And you basically have to make a decision in your key provider about which users should have access to that, so which public keys you give to the encryption engine. And the encryption engine will then take all of those public keys and encrypt a copy of the synchronous key for that. That make sense? So that's basically your access control layer in there. And that's why you may have noticed on the encryptable model, we have an array of key providers, because you may want to set up group key stores so that you've got a public-private key for a specific group. And you can then just set up a priority order of which key stores to use, and it will iterate through that, and the first one to return a set of keys will be used. That make sense? Okay. UserKey Provider. So this simple implementation, we basically just have this little helper method, get record user IDs. If we've got a special method on that particular model, then get user key provider IDs, and that means we can reuse this key provider across all of our models, and that will tell us which user keys to use for the given model. We also try and see if the record has a user relationship, in which case we use that ID, or we use the authed user. Cool. So by default, you'll probably end up with this one, that only the auth or logged in user will have access to the record. So to that end, I will migrate fresh, and then I'll go ahead and create my contact again, and you'll see the same thing. We've got encrypted records. If we grab name, oh, what have I done? I haven't fetched the record. Here we go. Fetch the record. Name is John. So if I exit this, I missed a step. I wasn't authed as anyone. So I can decrypt this record because it's the encryption key for it is stored on the model itself. Yeah, I did. Yep. Sorry, contact model. Oh, what? Whatever your authentication package is, the key thing in this case is that when I log in, so I just do a simple auth attempt, I grab the authed user, generate a random session token, then grab the decrypted private key that was created for that user, and of course I have to use the password one, but you can chop and change it for whatever you like. So at the moment, if we just have a look at that, I'm just using the standard cache driver to temporarily store the session keys with an expiry, just for example purposes. So now we'll go and create our contact. UserKey Provider not found because I haven't imported it. That will help. Got our encrypted model, ID 2. And we've loaded it in fresh from the database. And now if we say contact name, we've got the decrypted name. If I exit this Tinker session, load in again, don't authenticate, try and find that record, I can load the record fine, but I can't decrypt it. And you'll see it's just returned the ciphertext. In this case, we have an option for it to throw an exception instead. That's up to you. And that will become default in the next major version. So if we create a new user over here, where's my user? I'll just copy it over from here. And then we authenticate as Jane. And again, we try and get that user. Again, she can't access it. Login as John again. Grab the record, decrypt it, we're good. Sorry? If you do want Jane to have access to that record, then somebody who has access to that record needs to delegate it to her. So basically how that works is you have to find a copy of that synchronous key, decrypt it, re-encrypt it for the new user. So we've got a few helper methods in here that will help you to do that. But yep, it is something you have to think about.
I can imagine a situation where you have help desks. They need to be able to access the addresses of 50,000 users.
Yep, absolutely.
You get a new help desk start, there you go.
Yeah.
They now need access to all 50,000.
Yep. And that is one of the reasons why we have multiple key providers that you can define. So you can create a group key so that instead of having to loop through every single record and every single user that needs access to that record, you can use a single group key for a given set of permissions to encrypt all of that data and just have the one synchronous key record that you need to decrypt. So how that works is that each user then gets a encrypted copy of that specific private key. So when you're adding a new user, it's a really quick operation. All you have to do is, again, have a user with authentication to add that user, who can give them a copy of that private key, that group's private key. Cool. So that's pretty much it. I said I was going to talk a little bit about searching. So down the bottom of the documentation here, you'll see there's a few suggested packages or recipes. So obviously we've got the UserKey store that I've shown you today. We've got HashToSearch. So I'll just open that up and we can briefly go through this. This is another package that we've put together to deal with this particular use case. But again, there's a number of approaches to this, and we've taken several in our in our time of implementing this in production systems. The one thing you have to be aware of is this note. So how this search package works is essentially it stores a hash of every kind of character and uses that in search. Oh, this one's different? Oh, full text only. Yeah. So, yeah, sorry, every word in there. Yeah. And you can, so you can search on the field based on that hash. So when you do your search, you rehash the search term and then you search your database for that hash. But obviously there's a consideration. You have to think about leakage. So indexing rows that have the same value, they're likely to end up with the same hash, right? So if you use this for like last name, then people can use that information to predict who that person is. You'd be surprised, how sophisticated things can be to match all that up. So this reference is a really good article to help you make some of those decisions. Some other solutions are basically using something like Elasticsearch to... Craig, do you want to talk about this one? Because you've done it.
Elasticsearch set it up, and what you'd have to do is obviously set it up, get inside, return the fields, and actually encrypt it on that end. Then it does its own indexing search, Elasticsearch, which will return you an ID which you can then use to access your record.
Yeah.
The other one we did, which Sam was alluding to earlier, was where we actually encrypted each letter. The problem was that it became heavy on the documents.
Yep. Yep.
Pretty much gave up on that one quickly and moved it over to Elasticsearch.
Yeah. So that particular methodology works quite well hashing in Elasticsearch. It deals with that amount of data a lot better than a simple SQL table. But yeah, that's kind of the general gist of how you accomplish search. And sort, yeah, sort is a similar sort of problem. Basically, it's maintaining I'm just trying to think of how we've implemented it. Haven't done sort. Right, yeah. So essentially, it's I'll have to look it up and get back to you. Sorry. Yeah, yeah.
But more so than search. Hashing stuff and Elasticsearch works fine.
Yeah.
Search, but then how do you sort that?
Yeah. Yeah, I did do something on the very first iteration around sorting, but I just yeah. And this is an example package which puts together the user account recovery, which I was talking about before with secret question and answer. So just kind of helping you manage that. Again, it's slightly tricky, but the general gist is that you have some kind of secret that's not stored on the server that the user can provide at the time that you want to do the operation. Cool. Yeah, that's right. There were no. I mean, there's lots of low-level libraries that do the encryption part really well, and we're using the native PHP, OpenSSL seal and all that sort of stuff underneath it. We're not doing any of that encryption ourselves because that's just stupid. All we're doing is kind of handling the logic of the model events, getting the data encrypted, working out which keys or passing keys to the encryption library to kind of orchestrate all of that access control stuff. And there was nothing really very good that did things in a really secure way. A lot of those kind of libraries are more geared towards the convenience, which is great, but with convenience usually comes security issues. I would say this is probably overkill for most projects. It's more for, well, at least the whole UserKey part of it. That is more for your kind of bigger projects where you're storing a lot of personal information about a lot of people, or a lot of commercially sensitive information. Yeah. No, make a conscious decision. I mean, there is a performance impact, and there is a convenience impact. Some of the things, like I said, you can't do your mass update operations and that sort of thing, and that's a bit of a pain. Dealing with things in queue jobs is a bit of a pain. So you only really want to encrypt what you have to, but it's useful to have a tool there to do that when you do.
One question nobody's asking, probably wondering, existing projects can be used. The article command is on the screen.
Um, not, we have had, but nothing, I would say, unrecoverable, have we, Tim? Yeah.
With like encrypted data showing up on the client.
Yep, yep. It's one of the drivers behind throwing an exception when you can't decrypt something. Yeah. Yeah.
What about local development?
Yep, yep. It can, yeah, if you're using live production data, then in local development, which you shouldn't be, you should be using seeders and fakers and all that. But if you are, it can cause some challenges there. Obviously, you've got to think about keys. Who can access this data? Can you access this data? Should you? If you've got things all set up nicely with seeders and factories and that sort of thing, then it's not too bad. And if you have if you're using the global key provider, for example, in development, or you have a developer key provider, which gives your user access to everything, then yeah, it's not too bad at all.
In terms of like privacy in general, I guess not specific to this library, I did a code to there's that EU law, and they have a rule where it's like if the user wants to delete data, you've got to delete all records of their data.
Yep.
So we ran backups. Maybe we had backups for like 3 months or whatever, so you have to try and go through the backups and what it's paying out.
Yep.
With something like this, or this kind of thinking, is there going to be enough just to like revoke all the keys and like data's encrypted, we'll never see it again, or?
I don't know, you'd have to ask a lawyer.
Okay. I was thinking like you might have thought about this a lot and those type of things.
Yeah, it is a good point, yeah. I think because the legislation specifically says you have to delete or remove the data, then it wouldn't be enough. That would be my reading of it. And that would be probably what I would recommend to a client. But yeah. I certainly wouldn't take that as legal advice.
No, I think it's certainly an argument there you could make. It's like, I don't have any way to get to this, but I guess you've got a trust thing going on. So.
Yeah. Yeah, I mean that's right. It's probably from a legislator's point of view, you've got the encrypted data. Who's to say you don't have a key, hidden away somewhere?
Yeah. I think at the start is the New Zealand Privacy Act and all that kind of stuff. So I haven't read it.
Yeah.
Is there anything that would stand out in that from a legal perspective? Where you're like, oh, everyone should definitely know about that weird rule or something there?
There's very little teeth at the moment to the Privacy Act in New Zealand. That is likely to change. They have introduced some kind of criminal penalties, but that's more around data breach notification and that sort of thing. So if you do have a data breach, making sure that you're notifying the relevant authorities, like the Privacy Commissioner.
Yeah. So and the system set up, you have to say there's a data breach, but all your data is encrypted.
Yep. So the wording says something along the lines of a serious breach, and there's no kind of hard and fast rule around what a serious breach is, or one that is likely to cause serious impact. But generally speaking, it's like if you've got a large number of users compromised, or a large number of kind of driver's license numbers or that sort of thing, then that is a notifiable breach. Whereas this might help limit what might be classed as a notifiable breach. But yeah, that would certainly be a call for you to make.
I don't think that it would. Just because it's encrypted, it's still being breached.
Yeah, certainly my recommendation would be to notify if in doubt. Yeah, absolutely.
It certainly wouldn't come to GDPR.
Yeah,
absolutely.
Yep.
Absolutely wouldn't come to GDPR.
So the criminal penalties in New Zealand are around if you delete data that you've been requested to give out or something like that.
You can't just be like, oh, I lost it.
Yeah.
Any other questions? All right. Thank you, Sam.
Cool.